class. All right, so we watched the rest of the video called "The Mystery of Matter Out of Thin Air," and I'll tell you what I like about it. It's all these connections. Like if Volta had not discovered how to make a battery like that, then Davies wouldn't have had the instrument he had. He might have thought of something else to do, but he wouldn't have been able to do that. So anyway, what we're doing here, we're not changing gears completely, but we're going into the next level of chemistry. And this will actually push you to a new level of chemistry. And then we'll be pushed again, and then we'll get to the point where we start using mathematics. And I kind of like the way it progresses. But this chapter here, even though chapter 5, if you like to read, you can read the chapter. Now, I teach it a little bit differently than the author, and I know this works. I wish somebody would have taught this to me when I was in high school. I was not taught that there was a system. There is a system that you can learn, and you guys will be able to write formulas and name compounds for maybe, 5 to 10,000 compounds. We're not looking at 10,000 compounds, but you'll be able to do it. And I'll show you the rules they go by. So what I'm doing is I have divided it into 5 types. There are 5 types of compounds that I'd like you to be able to learn how to name them. And if you listen carefully, you'll see how type 3, for example, is kind of like type 1 and 2 and together. And you'll see type 4 is also its own little thing, but it's easy. And type 5 is the easiest one of all. And I leave that for last. So what we're going to do is I'm going to try to teach you what they call inorganic nomenclature. Now, what do you know about the word organic? Right. If you're a chemistry person, you know that organic means you're a carbon compound, right? Matter of fact, almost always you're carbon and probably hydrogen like that. But unfortunately, a group of people stole that word, and now if you go to a grocery store and you go to the organic vegetable section, what does that mean?
They don't use pesticides.
No pesticides, right? But guess what? Every vegetable is organic. Okay, but anyway, because it has carbon in it, doesn't it? Every piece of meat is organic. Everything you eat is organic. But today's organic means you didn't use pesticides to do it, okay? So this was around a lot longer before that. All right, next. So we're going to talk mainly about compounds that are not carbon compounds. If you go to college and you become a science major, it'll make you take 1 whole year of inorganic chemistry. That's 2 semesters. And then you'll take 2 semesters of organic chemistry, which is carbon chemistry. You get that? So, all right. Now, what I'm going to do here is the 5 types that we have. Type 1 is the simplest, but you have to know type 1 really, really well. Then when I show you type 2, you say, oh, type 2 is just like type 1 except for this one little thing. And then you'll understand it. So stay with me as long as you can. And I know we're only going to get to type 1 today, maybe. We'll see how far we get. But let's take a look. First of all, when we start writing formulas or naming compounds, group 1, type 1, says it's binary. What does it mean to be a binary compound? Only 2 elements. Got that? It says right here. And what does it mean to be ionic compound? Metal and a, very good.
Non-metal.
Okay, now, think again. Right here, it's just a little stair step. Now, not counting hydrogen. Hydrogen is really a non-metal, but see a stair step? Metal, 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 metal. Everybody get that? Those are all metals. Now, in the non-metals, they don't want to form compounds, so we won't be talking about them. So that only leaves a little group of elements here, and hydrogen. There aren't that many non-metals, are there? So when I ask you to look at something, if I say something like this, NaCl, is this a binary compound? It has only 2 elements, right? Is it a metal and a non-metal? Look. Oh, yeah. And one more. You have to be I call this an always metal. And let me tell you what the always metals are, and I'll say this about 20 times this week, so I'm sure you'll get it. Always metals, ready? Group 1A. Group 1A, the alkali metals. In a compound, they will always be +1 charged. They'll form a +1 ion, always. Group 2A, they will always form a +2 ion. Right, got that? And now there's only 3 more. Silver, zinc, aluminum. +1, +2, +3. Try it again. All the alkali metals in a compound will have what charge? +1. What about the alkaline earths? +2. And then silver, +1, +2, +3. If it's one of those metals, it belongs to type 1. Okay, now we're ready. Does this thing fit all 3 criteria? Well, then we're ready to name it. How do you name this compound? And by the way, the metal's written first. Notice that? The cation is always written first. How are you going to name this? What's the name of the metal? Now, this element is called chlorine. But in a compound, you drop the ending of the nonmetal and add IDE. Sodium chloride. Get it? So now, what if this was in a compound? The element's fluorine, but you would call it what ion? Fluoride. This is chlorine. The ion would be chloride. Bromine, iodine, iodide, oxygen, oxide, sulfur, sulfide, selenium, selenide, nitride, phosphide, hydride. Ooh. Everybody okay? Now, let's read this. Type 1. All binary compounds end in what? Okay, I can remember that. You don't know what the Roman numeral is, so skip that for right now. Do not look at subscripts to name the compound. For example, how do I name this right here? Sodium chloride. Now, see these little numbers here? Don't look at them. If it's a type 1, we don't look at them. What's the name of this guy? Barium chloride. What's the name of this one? Aluminum oxide. Notice that the numbers didn't matter, did it? The numbers didn't matter as far as me naming them. All right. All compounds have a net charge of 0. So let me show you how to write a formula. What is the most likely compound to form between barium and chlorine? Okay, here we go. Barium in a compound is going to be what charge? +2. That's always right, isn't it? Oh, by the way, is this type 1? How do I know it's type 1 again? Binary. Is it ionic? Yes. Metal, non-metal? Is this one of the always metals?
Hey, big game today. I expect everybody to come out to see us play GES today. And the theme for the game is going to be neon. So come out there in your best neon.
All right.
There you go.
Some years we play GDS's JV team, but some years we play their varsity. GDS gives money for scholarships for people to play there, so they usually have a very good team. Is that right? Is that what's going to happen tonight? Are we going to be playing the varsity? Or our varsity playing our varsity? Ooh.
I don't play.
Oh, okay. All right. Well, anyway, let's go here. Now, so now I want to show you a little trick here. Watch. Let's look at the nonmetals. These don't want to form compounds, so we leave them alone. These in a compound want to be -1. These want to be -2, and these want to be -3. Remember that last chapter we did a little of that? Okay, so guess what? What am I going to put here for chlorine? -1, right? Well, this cannot be a compound because all compounds have a net charge of 0. So how can we make it have a net charge of 0?
2 chlorines.
Teresa. Now, if you had 2 chlorines and each chlorine is -1, that would be -2. What's -2 and +2?
0.
We have it. We have it. We have a compound here. What's the name? Barium chloride. Whoa. Let's do another one. What's the most likely compound to form between calcium and nitrogen? Uh-oh. Let's see. In a compound, +1. Uh-oh. plus what? Plus 2. Riley, you with me? I don't think so, are you? Okay. What's the charge of nitrogen in a compound?
It's -2.
What?
-2.
Minus what?
2. 3.
3.
Yeah.
Did you say 3?
Yeah.
That's what you meant to say, okay. Now, here's the trickiest one of all, because how are you going to make this have a net charge of 0? And I'll show you, whenever you have like an odd and even number like that, what's the smallest number that 2 and 3 both go into? 6. What times 3 is, what times 2 is 6?
3.
What times 3 is 6?
2.
There we go. Will that work? -6 plus 6. We have ourselves a compound here, don't we? What's the name of this compound? Calcium nitride. What do you think? Now remember, type 1 is the easiest, but if the more you know type 1, when I show you type 2, you say, hey, that's almost the same. What do you think? Can we do this? Can I give you a hint? Do not underestimate this stuff. If you stay with me and you practice it, you're going to get good at it. Some people absolutely kill this test, and some people bomb this test. Okay? So all I'm asking you to do is you stay with me as we go through that and just progress, and we're going to be okay. We're going to practice and practice and practice. Okay? All right. Well, you have a good day, and I don't have to do any